What if the most mysterious visitor in our solar system suddenly slammed on the brakes? In mid-2025, something extraordinary happened. NASA, the James Webb Space Telescope, and ground observatories worldwide caught the third known interstellar object, 3I/Atlas, doing the unthinkable. Its velocity dropped by up to 8 meters per second. This isn't just unusual. For astronomers, it's statistically undeniable. And if confirmed, it could change how we think about interstellar objects forever. Stay tuned, because in this video we're unpacking the new data, the urgent cross-checks, and the theories about what could possibly slow down an object racing between the stars. Most of us remember the name Oumuamua, the cigar-shaped visitor from 2017 that defied our expectations. Later came 2I/Borisov, a more normal comet-like body. But in 2025, astronomers confirmed a third interstellar visitor, 3I/Atlas. Initially it looked like another comet from the depths of space. But the closer scientists looked, the stranger it became. By July 2025, three powerful eyes, NASA's ground-based Atlas survey, the James Webb Space Telescope JWST, in infrared, and the Neil Greill Swift Observatory in ultraviolet, were all following its trajectory. And then the numbers started to wobble. On paper, an interstellar object should act like a bullet. It comes in fast, swings by the sun, and races back out without losing significant speed, except for minor, predictable effects from gravity and outgassing. But between late July and early August 2025, 3I/Atlas did something new. Its velocity dropped by 6 to 8 meters per second in just a few days. To put that in perspective, imagine a car speeding at highway velocity and suddenly losing 20 to 30 kilometers per hour without brakes, friction, or air drag. For an object hundreds of millions of kilometers from Earth, in the vacuum of space, that shouldn't happen. At first, the teams thought it had to be a mistake, maybe a calibration error, maybe solar drag miscalculation. But urgent checks kept coming back with the same answer. The slowdown was real. As soon as JWST flagged the anomaly, Swift turned its ultraviolet instruments on the comet. Ground-based telescopes, Pan-STARRS, ZTF, Atlas, began feeding data to the Minor Planet Center for immediate cross-checking. Within days, astrometric logs, photometry, and trajectory models piled up. All pointed to the same thing, a measurable deceleration outside the normal error bars. Dr. Jean-Christophe Pellet at the University of Hawaii went public first. No other known interstellar or long-period comet has shown this kind of motion anomaly. By mid-August, the once obscure object was the most scrutinized body in the solar system. NASA's official line, voiced by JWST team lead Dr. Natalie Battaglia, was cautious. "We are seeing something we did not anticipate. Additional observations are needed to understand the underlying physics." At the same time, Swift's photometry hinted at water outgassing inconsistent with standard comet models. The JWST infrared images on August 6 showed thermal signatures that didn't match predictions. Every time the teams reran their models, the anomaly stayed. If the slowdown holds, 3I/Atlas would be the first interstellar object ever observed losing speed inside our solar system in a way physics can't yet explain. That's bigger than it sounds. First, it could mean we're witnessing a new kind of natural phenomenon. Maybe interstellar comets form with exotic ices or dust that behave differently near the sun. Second, and more speculative, some researchers whisper about the A word, artificial. Could 3I/Atlas be a probe, a derelict craft, or something built to use the sun's gravity for braking? It's far too early to say, but the mystery is now front-page news in astronomy circles. NASA's JPL Horizons database, updated nightly, shows the subtle but undeniable kink in 3I/Atlas's outbound path. Astrometric fits from multiple observatories align, the deceleration is persistent. Teams are running calibration drills, reprocessing every pixel, hunting for hidden biases. But the anomaly won't go away. For a field used to millisecond precision, the numbers do not stutter. That's the phrase one researcher used. If you thought Oumuamua's acceleration was a puzzle, this slowdown pushes us into uncharted territory. Continuous monitoring is now underway. Every major observatory with a clear line of sight has pivoted to 3I/Atlas. The European Space Agency is even considering retargeting its Comet Interceptor mission to gather data. Because if we can understand what's happening with 3I/Atlas, it could teach us not just about one strange visitor, but about the physics of interstellar travel itself. Imagine a natural mechanism, or an engineered one, that can slow down a star-crossing object without fuel. That's interstellar braking technology. That's science fiction becoming real data. By late 2025, more high-resolution spectra and photometry will pour in. If the slowdown persists, it could trigger proposals for a fast intercept mission, just as NASA once dreamed about sending a probe to Oumuamua. This is why astronomy is thrilling. The universe keeps throwing us curveballs. The third confirmed interstellar visitor may be rewriting the textbooks in real time. As Dr. Battaglia said, "We are seeing something we did not anticipate." Those words echo across the astronomy world. So what force is acting on 3I/Atlas? Could it be a new kind of cometary physics, or the first hint we're not alone? For now, nobody knows. But the numbers don't lie. If you're new here, subscribe. This is exactly the kind of story where one small anomaly today becomes tomorrow's paradigm shift. And the next data release could change everything. Stay curious. Stay skeptical. And keep looking up, because 3I/Atlas isn't done surprising us yet. Subscribe for more. We cover the newest space discoveries, interstellar mysteries, and science that makes headlines. Don't miss the next update, it could be historic. Thank you for watching my channel.